Today we're going to look at the distance on the coordinate plane. So let's just look at two random points on the grid. So we've got 2 points here, 3, 0, and 7, negative 5. So I'm going to plot those. 3, 0. Let's then plot 7, negative 5. And then we're going to connect these two because we're looking at the distance between these 2 points. When we have just a vertical line or a horizontal line, it's easy to kind of count the boxes or the grids to figure out the distance. With this diagonal, we don't know the exact measures. So what we can do is we can turn this into a right triangle. Just going to kind of draw a dotted line here and a dotted line here. This would be our A value, this would be our B value, and this would be our hypotenuse, our C value. And remembering, our formula just kind of flipped around with the hypotenuse first. C squared equals A squared plus B squared. But let's pretend that these are some unknown ordered pairs, right? We want to think of this for a scenario that could work in any type of ordered pair. So let's say this is our first x, x1, and our first y, y1. And at this point, it's our second x, x2, and our second y, y2. So our x values, if we were trying to find the distance between those, we can subtract them, right? Our x2 minus our x1 would tell us that distance across there, right? 7 minus 3 is 4. 1, 2, 3, 4. So in our formula, I'm going to write that and say, okay, the difference would be our x2 minus our x1. That would give us our a value, but it's not just a, it's a squared. For the y values, same thing, but with the y's. We can take our y2 and subtract our y1 to find that distance there. So our y2 minus our y1, and again, that will tell us our b value in squared. And thinking about this too with the squared, for the x values, we had 7 minus 3, which is 4. That was a positive value. That works out fine, right? But for the y values, we do negative 5 minus 0 is negative 5, right? We don't have negative distances. But when you square it, no matter what, it's always going to turn into a positive. So it actually works out either way that you would do it. Now, when we're actually solving, right, we don't want to know what c squared is. We want to know what c is. So to solve that, we would take the square root. Well, if I take the square root from this side, I would have to take the square root from the whole entire side, right? So, to find c, we take the square root of x2 minus x1 squared plus y2 minus y1 squared. You have to do everything in the square root first before taking the square root. All right? So this is the formula that we're going to be using. Let's go ahead and put it into action. Okay, it's up on the top if you need it. So finding the distance between the 2 points. I know the distance equals square root. I look at my x's. I'm going to highlight them for each. And my y's. Technically, it does not matter which x value I start with, okay? All that matters is you kind of keep it consistent, all right? So, let's say I start with this first one here, 4 minus 2 plus I just kind of then start the same way, 5 minus 2. So we're going to have to square those, and now let's go ahead and evaluate here. So I'm going to work within the parentheses first. 4 minus 2 is 2, so we're doing 2 squared plus 5 minus 2 is 3, 3 squared. So we're going to evaluate here. 2 squared is 4 plus 3 squared is 9. 4 plus 9 is 13. Then the square root of 13 is about 3 6/10. Let's try it again here. So we're plugging into our formula. Let's say I start with this x value first. 1 minus. Now be careful with the negatives. That's where people will start messing up. I'm not subtracting 3, I'm subtracting negative 3 squared plus our y value, 3 minus 4 squared. So 1 minus negative 3 is 1 plus 3, or 4 squared. 3 minus 4 is negative 1 squared. 4 squared, 4 times 4 is 16, plus negative 1 squared, negative 1 times negative 1 is 1. Now remember, the reason that the order doesn't really matter which way we do it, because if I had flipped this around, 4 minus 3 is 1, 1 squared is still going to give me 1. That squaring kind of cancels it out. So we get the square root of 17, which is about 4 and 1/10. All right, number 3, setting up in our formula. Okay, let's say I start with this one, 2.5 minus negative 3.5 squared plus negative 1 minus negative 5 squared. Again, be careful with the negatives. 2.5 minus negative 3.5 is plus 3.5, which gives us 6 squared, plus negative 1 minus negative 5 is really plus 5, so negative 1 plus 5 is 4 squared. Six squared is 36, plus 4 squared is 16. 36 plus 16 is 52. The square root of 52 is about 7 2/10. Last one. All right, let's start with this x value, 3.5 minus negative 4 squared plus 1 minus 2.5 squared. Three and a half minus negative 4 is really plus, so we get 7.5 squared plus 1 minus 2.5 is negative 1.5 squared. 7.5 squared is 56 25/100 plus negative 1.5 squared is 2 25/100. When we add this up, we get 58.5. Take the square root, we get about 7 6/10.